Okay, we're going to look at exponential equations. Okay? Now, this is a rational exponent. This is kind of from yesterday's stuff. I just want to recap with it. First of all, this is a negative exponent. And if you guys recall from our negative exponent rules, let's say we had 2 over 5 to the negative 2. How would I make this exponent positive? That's right, we flip this. It becomes 5 over 2, positive 2. So even though it's a fraction, we do the exact same thing to make this a positive fraction. So we get 8 over 27. The fraction itself does not flip. It just becomes positive, 2 over 3. Now from there, because it's a rational exponent, we need to apply this to technically both of the numbers inside. Okay? So I can rewrite it if I like. Think of this almost like that product rule. There's a 1 here and a 1 here. I'm going to multiply the 1 by our 2 over 3. Okay? Because it's an exponent of an exponent. So this becomes 8 to the power of 2 over 3 over 27 to the power of 2 over 3. Okay? So we've got rid of that outside exponent now. I'll just write these as 1s here. From there, how do I write this as a root? This fractional exponent. Would it be the square root? What is it? What type of root? That's right. We're going to be looking for the cubed root of both of these, and then we're going to put it to the exponent of 2 after. So as we write it as a root, it becomes the third root of 8 to the power of 2, and the third root of 27 to the power of 2. Okay. Third root of 8. Hold on, you missed a couple of days. I'll come back. I'll get you in a second. Third root of 8. That's right. It is 2. Okay. So then we have 2 to the power of 2. What is the third root of 27? 3. So we have a 3 to the power of 2. We still have a bit of work. 2 squared. 4. 3 squared. 9. So, from here, we went through 1, 2, 3, 4. It took us 5 steps to get to another answer that is a very close fraction to what we had. Okay? But that is essentially everything we've learned up to this point dealing with negative exponents, fractional exponents, okay, and bases that are fractions. That's pretty much a recap of yesterday. Okay, today we want to focus on when our exponent is a value of x. Okay, and the idea here is that in order to isolate for x, we need the bases to be the same. Right? So when the bases are the same, essentially we can cancel the bases out. In this case, we have a base of 5 and a base of 5. Because they're both base 5, think of it like canceling it out, and now we're left with x is equal to 6. There's nothing else to do there. The only thing we need to do is get the bases the same. So this one was relatively straightforward. X equals 6. And that makes sense because 5 to the power of 6 is equal to 5 to the power of 6, right? If we had replaced the x with that, it would say 5 to the power of 6. Okay, our second example is a little more difficult. The tough part is actually getting the bases to be the same. So assuming they've given us numbers that have equivalent type bases, what that means is I can write 32 as base 2 to some power. But I may not know off the top of my head what number that is. So something we can do, which we talked about the other day, is we can break this into prime numbers, this 32. Okay? So I'm going to take the value of 32, and I'm going to break it into factors until I get down to factors that are only prime numbers. Who can think of two numbers that multiply to 32? Multiply? Multiply. 16 times 2? Okay.
No, I thought you were talking about same numbers.
That's right. They will have to be same numbers. We're going to keep breaking this down. Can I break 2 into 2 different numbers? Let's focus on 2 to start. No, 2 is a prime number, so I can't go any farther with 2. So I'm going to underline it. I can break 16 into 2 numbers. Anyone know? 8 and 2 again. We already know 2 can't go any farther. Can we break 8 down? 4 and 2. And then what do we break 4 into? Okay. So we have 1, 2, 3, 4, 5. I can multiply 2 5 times. So we can break 2 into 1, 2, 3, 4, 5 versions of 2. So 2 multiplied by itself 5 times. 1, 2, 3, 4, 5. And that will equal 32. So what that means is I can rewrite 32 as 2 to the power of 5. And try that in your calculators to see if it works. Is equal to 2x. What is 2 to the power of 5?
32.
It's 32. Okay? So 2 to the power of 5 is just another way to rewrite 32. Now that the bases are the same, we can drop the bases off, and we have x is equal to what? 5. So the answer to this was x equals 5. Unless you memorize the powers of 2, it's one of the best ways to do it. So let's look at another example. I have 7 and I have 49. Let's always try to think of it as whatever the larger number is, we'll try to break that number down. Okay? So, I'm going to look at 49 and I want to break it into prime numbers. So who can give me 2 factors of 49? 7 times 7. Perfect. Can I break 7s down any farther? No, I can't break them down any farther. And they're 2 numbers that are the same. So we know that we can split this as 7 times 7. And will that give me the same base as before on the other one? Yeah. So I'm going to replace 49 with... Sorry. Should have moved this over a little. I'm going to replace 49 with 7 to the power of 2. Now over here we have 7 to the power of 3x minus 4. A little more complex. What can I do now with the bases now that they're the same? Cancel them out. Now I'm left with an equation. 3x minus 4 equals 2. Am I done? No. I need to move it over. I'm going to move this over here. We need to isolate for x. So the first thing we're going to need to do is move the 4 to the other side, which will give us 3x equals, what is 4? What will it become on the other side? Which is what? 6. How do I get the 3 to the other side? We got to divide by 3, which will give us what? X is equal to 2. Okay. So in this case, our answer is x is equal to the value of 2. So we had to break it down into an exponent with the same base, and then from there work out our equation. Same idea here. Okay. I have 3 and I have 27. I'm going to try breaking down the larger number. So let's focus on 27. Can anyone give me 2 factors of 27? Okay, 9 and 3. 3 is a good one, right? We're trying to get to base 3. And we know we want to stop at that 3 then. Can I break 9 into any numbers? 3 and 3. So what does that mean for 27? We can break 3 into 3 to the power of 3. But we originally had an x here. So I want you to keep that x in brackets. So what I mean by that is we're going to rewrite 27 as 3 to the power of 3. And then it's going to be multiplied by whatever was left there. Now in this case, because the x was there before, we split 27 into 3 to the power of 3. I'm going to multiply these exponents. What's 3 times x? Just 3x. Okay. Had it been more complex, we would have had to do a little more multiplying. Now on the left side of the equation, everything else stayed the same. We didn't do anything there. Do we now have bases that are the same?
Yeah.
Both the bases are the same, so we can drop them off. That's going to leave us with 5x plus 8 equals 3x. Okay, and I'll highlight that so you guys can see. We took this equation and this equation and set them equal to each other. Are we done? Do we know what x is equal to? We have to isolate. So I'm going to move all the x's to one side and all the constants to the other. When I move 3x over, what does it become? Yeah, so we'll subtract by 3x, which will make this 2x. This will become negative 3x over here. So we'll be left with 2x plus 8 equals, what would be on this side if I move the 3x over? 0. And then, Michael, when we move it over, what does it become? That's right. What do we do next? That's right. It becomes negative 8 when we move the 8 over. So 2x is equal to negative 8. Are we done? What do we got to do? Gotta divide by 2. X equals negative 4.